Hey, so today we really just did a review of solving word problems involving s equals r theta and a equals 1/2 r squared theta. So we're going to go ahead and do some practice problems that come straight from webassign. Your questions are probably going to be a little bit different. You'll have different numbers, but the same concept is going to get covered. One thing that we went over in class today is we kind of completed what's called a unit circle, and we talked about, hey, how many degrees does it take to get to a certain part of the circle, provided that you start on the x-axis with your initial side, go through, go through the origin for your central angle, and continue around. So we filled this out in class. When you get back into class, you can fill this out too. It basically just kind of gives you a nice conversion between classic degree angles and radian angle measures. Okay. All right, so all I'm going to do is I'm just going to go through a couple of the questions that you're going to see in webassign. So one of the first questions that you're going to see, I'm actually going to go back one, is this one here. This is question number 1 on webassign. Your number might be different, but here's the concept. It basically says, go ahead and solve for theta within 2 decimal places, given that r is 80 and s, the arc length, is 56. All you need to do here is use the equation s is equal to r theta to solve this situation. So if I plug in 56 for s, plug in 80 for r, divide by 80, what we're going to get is 0.7. So you might think, where did the negative come from? I know this is really tiny here, but you're going to see a downward arrow. That's going to say that this angle here is negative. And so the answer here is negative 0.7. This is a pretty easy question. Let's go ahead and move on to one that maybe is a little bit more challenging. All right. So this one right here is, let me move my face. This one here is question number 2. It says, find the area of a sector of a circle with radius r and central angle theta, and then round your answer to 2 decimal places. All right, so what's awesome about this question is don't read into it. Basically, the question kind of answers itself. We know that the area of a sector is equal to A. So A is equal to 1/2 r squared theta. All we need to do is plug in the information. What's so awesome about this situation is that the central angle theta is already in radians, which is really important because this equation requires that theta is already in radians. So really the work is already done for us. Plug in 6 for r, plug in theta as pi over 6, and then go ahead and simplify. Whatever 3 pi is, which I don't have my calculator on me, but it's probably like 9.4 or something, go ahead and round that to 2 decimal places. So make sure you plug this into your calculator. Okay, next one, number 4. So I skipped to number 4 because this can be a little bit confusing sometimes. All right, so number 4 says a voltmeter is 6 centimeters in length. It says find the number, and I highlighted here, of degrees through which the pointer rotates 1.8 centimeters. So when it rotates 1.8 centimeters, what it means is that right here, on the voltmeter or whatever voltmeter, that's how much movement it's making on the arc length in essence. So it's a curved surface. So we know that 1.8 is S. We also know that the voltmeter is 6 centimeters in length, which means R is 6. If we set up S equals R theta, this is a pretty easy question to answer. We're going to put in 1.8 for S, and we're going to put in 6 for theta. If we divide by 6 on both sides, we're going to get 0.3 radians. And be careful here. The reason I know that the answer is 0.3 radians is because theta has to be in radians. That's just kind of how our equations are set up. And so because theta must be in radians, my answer here is in radians. But that's not what the question is asking for. The question says find the number of degrees. So what the question is asking you to do is take your answer that's in radians and go ahead and convert it into degrees. So I want to know, how do I go from radians to degrees? Well, it's a unit converter. If radians are in the numerator, I want radians to be in the denominator so that they cancel. So I'm going to multiply 0.3 radians times 180 degrees divided by pi radians. And what we're going to end up getting here, if you plug this into your calculator, if you say 0.3 times 180 divided by pi, you're going to get 17.19 degrees. So be careful here. This whole topic that we've been going over this week really just has to do with changing your measurement scale. So changing from degrees to radians is really similar to changing from inches to feet. So just remember that. I think we might have one more question I want to cover. All right, so the last question, it says, a car's rear windshield wiper rotates 120 degrees. It says the total length of the wiper mechanism is 21 inches in length and the wiper blade is 15 inches. So let's find the area round to one decimal place that the blade touches. Best thing you can do here is draw a picture. So we can see that there is some sort of windshield wiper, and we're all kind of familiar with this concept that, the windshield wiper doesn't get everything, which is unfortunate, but, name of the game. Windshield wiper's blade is only so big. It's here. And so when the windshield wiper rotates, it only rotates within where the blade is at. So we only get a little bit of the area and a piece is missing. The piece that's missing, well, if the whole length of the mechanism is 21 and the wiper blade is 15, then the difference must be 6. And so we know the radius of this little tiny area is going to be 6. And then the radius of the big red area is going to be the bigger number, which is 21. So in essence, in order to find this, you're going to have to subtract the red area from the black area. The red area is found using the area formula. We're going to use 21 as the radius because that's the radius of the whole mechanism. And then we're going to multiply by theta. Now note here that we were given 120 degrees. That's how much we rotated. But none of these formulas are set up to use degrees. So I'm going to change 120 degrees into radians. And here's how you do it. Take 120 degrees, and I want degrees to cancel. So I'm going to put degrees in the bottom. 180 degrees are in pi radians. If I multiply this out, degrees are canceling. There's a 10 that I can cancel. And 6 goes into 12 2 times, and 6 goes into 18 3 times. And so what we get is 2 pi over 3 radians. And that's what I'm going to plug in to my area formula, which is going to give me this number right here. I think I rounded it to some crazy decimal places. Next one, the black area. Black area is the same, except this time its radius is tiny. It's a tiny 6 that came from subtracting 21 with 15. Its theta is also going to be the same. It's still rotating the same amount. And when you plug that in, you're going to get 37 approximately. If you subtract the 2, what you're going to end up is with 424.1. And it says we started off in inches, so we're going to make sure we write inches at the end of that. All right, so those are the basic word problems that we went over in class. If you have any questions, once again, feel free to send me an email. I would love to help you out. All right, have an awesome day.